This video covers pointers as used by C and C++. Sometimes pointers can be a little bit difficult to understand, so you may want to look at this video more than one time. The topics covered in this video starts off with simple variables, just as a review. Then we'll see how we can use pointers when we're working with variables. I'll discuss pointers and arrays, pointer arithmetic, C strings and pointers, and multi-dimensioned arrays. Here's some stuff on simple variables. I have three variables here, a, b, and c. I'll start off and assign 20 to the variable a. Then I'll say b equals a, so that 20 is going to be copied into b. C equals a plus 5. Now I'm doing a little bit of math. Here's a math expression, so I'm taking the contents of a, which is a 20, add 5, and store it in c. So variables and constants are stored in memory. Each memory location has an address. A 32-bit integer uses 4 bytes of memory, and addresses are usually represented in hexadecimal. Memory addresses below are just examples. For example, the location for A is at memory address location 48394. B is at 48398, and C is 4839C. Since I'm working in hexadecimal, when I add 4 to each location, the last one ends up with a 4839C. Here is a definition for pointers. A pointer is a variable that holds an address of a memory location. Pointers are declared using the asterisk. The ampersand is the address of operator. Right here I have int a equals 20, so I have a variable named a, and the contents is 20. Int star ptr equals ampersand a. What I'm doing is declaring a pointer by the name ptr. You don't have to call it ptr, but that's just what I happen to call it here. Star in front, when I'm doing the declaration, means I'm declaring a pointer. Ampersand a means the address of variable a. So I have a 48394, which is a memory address, and that gets stored into ptr. The other thing to notice is that it says int star ptr. Well, the contents of ptr is a memory address, not an integer. Int star ptr, the int star just means that I am pointing to an integer. A pointer must be initialized to the address of data before it can be used. I can set the address at the same time I am declaring the pointer. For example, I could say int star a ptr equals ampersand a, or I could do it in 2 steps and say int star a ptr, and then a ptr equals the address of a. What is the pointer pointing to? Here are several examples. Int star a ptr, this is pointing to an integer. Double star b ptr, pointing to a double. Character star c ptr, pointing to a character. Null star d ptr. Well, this pointer is going to hold a memory address, but I really can't use it yet because I don't know what it's pointing to. One way to solve this problem is to cast dptr to an integer or double or something else, so that now we will know how to use it and what type of data it's pointing to. Here's another thing I could do is a ptr equals null, and that means that it's like we have a bunch of zeros in there, so we really can't work with memory address location 0, but at least I have a pointer and something's in there. I just can't use it yet. How do we use pointers? It's called dereferencing. This code shows 2 different ways to put a 20 into memory location A. One way is to say A equals 20. Another one is using a pointer. So int star a ptr creates a pointer. I'm setting that to the address of location A. Then star a ptr equals 20. I can also add a plus 5 equals 25 and store it into B. Instead of saying a directly, I'm going to go through the pointer and say star a ptr, which contains the address of A. So star a ptr goes and looks up A, which is a 20, and then adds 5 and stores it into B. So now B is a 25. There are many different uses for the star. I can use the star when I'm declaring a pointer, such as int star a ptr. I also can use the star when I'm dereferencing the pointer and looking up the contents of A. So if I'm not declaring it, then I'm using it to look something up. I can also use the star for multiplication, so it kind of depends on where that star is used as to what its meaning is going to be. There's also several different uses for the ampersand. The ampersand in front of a variable, that means the address of the variable. I can also use the ampersand to do a logical AND or a bitwise AND. A bitwise AND has not been covered yet. Pointers and arrays are very closely related, as we shall see when we compare pointer notation and array notation. I'll also cover pointer arithmetic, incrementing, decrementing pointers, and how we can use pointers with C strings. One of the things to remember is that the name of an array is the address of the array, so it's very easy to store the address of an array into a pointer. An array is passed to a function by its memory address, not by the full array. For example, if we tried to pass the full array to a function, that would be an awful lot of data to send from one spot to another, because we never really know exactly how big the array is. So we just pass the address of the array. When accessing data from an array, I can use either the array notation or pointer notation. Both work equally as well. Here's my array. Again, I say int class size and a bunch of data. 32, 27, 29, 23, 68. So I have 5 pieces of data in my array. I'm creating another variable. It's an integer, and I want to take some data from the array and stick it into my class. I could say my class equals class size and then sub 2. That's going to get me the third element in the array, which is going to be a 29. I could use the pointer notation just as well. I could say int my class equals star, and then in parentheses say class size plus 2, close parentheses. That's also going to get me the third element in the array, which is a 29. I have to make sure I use those parentheses. Here's a little bit of information on pointer math. So starting off again with declaring my array, int star class size equals, and here's all the elements in the array. I'm creating a second pointer here that's going to point to integers. I just call it PTR. So int star PTR creates the pointer equals class size. I don't need the ampersand here because the name of the array is the address of the array. Here is a third variable called score. I'm going to pull data out of the array and put it into score. I can say score equals star PTR. This will get me the first element in the array. I could also say score equals, and then the square brackets, a 2. That's going to get me the third element in the array, so I'll get a 29. I could just as well say score equals star, and then parentheses PTR plus 2. That would get me the 29 again. Well, what happens if I increment PTR? If I increment PTR, now I'm moving PTR to point to the next element in the array. So if I say score equals star PTR, I get to 27 because now PTR has the address of that element, the 48398, so I get to 27. How about if I say class size plus plus? Well, that's illegal because class size is not a variable, so I can't mess around with that pointer. Here's a little bit more information about pointer notation. When I say class size plus 2, what happens is I have class size, which is 48394, and when I add 2 to it, it's really adding 2 times the size of the element. So if an integer is 4 bytes, then it's 2 times 4, and that's done secretly. So it automatically moves down to the next element. In this case, I'm moving 2 elements, so I'm moving 8 bytes. So I'm going to end up with 48394 plus 8. And using hexadecimal math, that's going to give me 4839C, which is going to be the address of right there where it's index 2, or the third element. Here's something you have to watch out for, and this has to do with using those parentheses. Am I adding to the pointer, or am I going to be adding to the data? If again, if I say int my class, and that's a variable, I'm going to pull data out of the array and stick it into my class. Int my class equals star parentheses class size plus 2, I get 29, which is going to be index position 2. However, watch out for this one if I say int my class equals star class size plus 2. Well, the parentheses are needed because the asterisk has higher priority than the plus. So right there, what's going to happen, it says star class size is going to go and pick up the 32, which is first element, element 0, and then add 2. So I get 32 plus 2, which is 34. Well, what happens is I either pick up index 2, which is the 29, or I pick up the first element in the array, index 0, and add 2 to the 32, end up with the 34. Let's look at C strings. A character string in C language is stored as an array of characters and is terminated by null byte, which is all zeros. So if I have character message equals, quote, hello, H-E-L-L-O, what I get is H-E-L-L-O, and then the null byte. If you look at this, the double quotes is used for a string, and a single quote is for a single character. Those codes are based on the ASCII character set. ASCII stands for American Standard Code for Information Interchange. Well, the ASCII set has been expanded so that we can have characters from all sorts of different languages. ASCII forms the first set of characters in Unicode, which is the expanded character set, so I can still look right here and think of ASCII. You have to remember that everything in the computer is stored as ones and zeros. The ASCII set is based on the old teletype paper tape. A is a 41 hexadecimal. So if here's hello, I have a 48. And then a lowercase e is a 65. A lowercase l is a 6c. I have a second L. And then the O is hexadecimal 6f. So far, so good. Now, where it says 0x48, because in C and C++ and many other languages, to specify a hexadecimal value, we started off with 0x. If I don't have the 0x, that means I'm specifying a decimal value. But you really have to watch out here, because if you start off with a leading 0 and no x, you're specifying a value in octal. And it doesn't get used too often, but that's what the language is going to do if you start off with a 0. Here's a null byte terminator. So hello, if I specify hello with the quotes, C and C++ automatically stick a null byte at the end of the string. However, if you specify the string yourself with individual characters, then you need to put in the null byte. For example, if I say character message H-E-L-L-O using individual characters, I have to put the null byte in. If I use hexadecimal, I can say 0x48, 0x65, 0x6c, 0x6c, 0x6f, and then put in the null byte. So the pointer notation could also be used here. Whether I use the array notation or the pointer notation, I can still load up an array and initialize it at the same time. Now, the size of a C string means the number of characters, so that's string length. And you can get that there's an strlen function, which is part of the C string functions. So strlen is going to tell me how many characters are in the string, not counting the null byte. Anytime you're working with a string and you create the array yourself, you have to specify the number of characters that you want plus 1. You have to make sure that you leave room for the null byte. We can either specify the null byte as NULL, or a decimal 0, or a hexadecimal 0, 0x00, or as a character, I have to put the backslash there. So it'd be quote, backslash 0, quote. So I'm specifying that I'm creating a numeric value of 0, you have to watch out, because if you use a single quote, 0, single quote, that's going to give you character 0 out of the ASCII character set, which is hexadecimal 30. It's not a 0. Here are several ways of using C++ to display a string. I'm creating a string character message equals quote hello quote. So I have HELLO and then a null byte, right? Okay, I could say cout less than message. Cout already has built into it the ability to display a C string. It's going to display the string and stop when it sees the null byte. I could also use a for loop here. If I already know that there's 5 characters in my string, I could say for int I equals 0, I is less than link, I plus plus, cout message sub I, and we're going to go through this for loop 5 times, displaying individual characters HELLO. Instead of worrying about how many characters are in the string, because that means I have to count it ahead of time, how about doing this? I could say display until the null byte is reached. For int I equals 0, message sub I is not equal to a null, I plus plus, and then cout message sub I. I is going to be incremented 0, 1, 2, 3, 4, 5, and when I end up with I equals 5, then message sub I is going to be a null byte, then I'll fall out of the while loop. Well, I can do the same thing without those curly braces because there's only one instruction in the for loop. Now, some languages won't allow you to get rid of those curly braces, like Swift. It's a new language from Apple. But if you're working with C or C++, you can get rid of those curly braces if there's only one instruction that's part of the for loop. Why compare to null? Here's version 1. Version 1, I'm saying message sub I is not equal to a null, but the definition in C and C++ for true and false. True is anything that's non-zero, and false is anything that is 0. So why compare to null? I could just say message sub I, because the H, the E, the LL, and the O numeric values are, it's not a 0. But when I get to the null byte, I end up with a 0, which means false, and I'll fall out of my for loop. How about using a pointer instead? For ptr equals message, so I'm initializing my for loop, and I say ptr equals message. So now ptr contains the address of the first byte of the array. I look star ptr, so I'm going to look to see if the value is a 0 or a non-zero. If it's non-zero, that means I have a character and I need to display it. So I'll do the cout. The last thing in the for loop, I'm going to increment the pointer. I'll work down, starting at 48394, 38396, 38398, 38396, 38398E, and each time I'll get the data from those memory locations and display it. Eventually, when I end up with 383A0, I'll pick up the null byte, I'll fall out of the for loop, and stop displaying. When passing an array to a function, just provide the name of the array. Since the name of the array is the address of the array, this is all that's necessary. It's also important many times to pass the size of the array, since C-type arrays do not include the size of the array as part of the array information. C++ and Java have something called an array class that includes the size of the array, but for a standard array in C and C++, the size of the array is not included, so you may need to pass the size of the array or have something else that you can use to indicate when the end of the data in the array is. Now, if I'm passing a string, I have the null byte terminator, so that's good enough. Here's an example of passing an array to a function. In this case, I'm passing a string. I don't need to specify the size of the string because we can stop when we reach the null byte. In the main part of the program, I have my function prototype, void display message, and a character star that identifies the type of data that's going to be passed. You can, if you want, put in a name, but it's really not required for the function prototype. Later on inside main, character message equals hello, and then display message, and I'm passing MSG, which is the array, and I'm passing the array to the function. So inside the function, I say character star PTR. I'm going to receive the address of the string, and it's going to be stored in a local variable called PTR. That's a local variable just within inside the subfunction display message. I can do anything I want, change it, increment it, decrement it, whatever I need to do, because I'm not going to modify anything inside the main program. Inside the function, I have a while loop, while star PTR, so I'm looking for the null byte. As long as I haven't reached the null byte, that value is non-zero. When I reach the null byte, I end up with a 0, I fall out of the while loop, and I return from the function. So it says while star PTR, C out star PTR plus plus. We have to look at these things because star PTR has higher priority than the plus plus. And it's going to display whatever's at star PTR, so I'm going to display the H. Then plus plus increments the pointer. Now the pointer will be moved down to 48396, which is going to point to the E. Go back to the top of the while loop and say star PTR. The E is non-zero, so I'll display star PTR with C out, increment the pointer, so the pointer moves down to 48398, which is the L. Go back to the top of the while loop, star PTR, looks at the L, says, that's non-zero, goes down to C out star PTR, displays the L, increments the pointer, and that happens at the end of that line. So then I go back to the while loop again at the top. So eventually I'm going to get to the null byte. So once I increment the pointer to 483A0, I'm going to pick up and look at star PTR, and I'll see the null byte. I'll stop because that's a false. I'll fall out of the while loop, and then I'll exit the function and go back to main and continue wherever I left off after display message. Here's some information about multi-dimensioned arrays. Double-dimension arrays are implemented in C and C++ as an array of pointers to arrays. Have you ever noticed the line for main where it says int main, int argc, comma, character star, argv, open, close, square brackets. For example, here's a multi-dimensional array. Suppose I have 9 students with 5 scores for each student. The way I could initialize the array, I could say int class scores, open square bracket 9, close square bracket, open square bracket 5, close square bracket, and then a list of all my scores. So I'm going to start off with an open curly brace at the beginning of my definition, and then there's a closed curly brace all the way at the end. So inside those open closed curly braces, I have another set of open closed curly braces for each row. And then I'm defining the data for each row. For example, if I want to pull data out of the array and store it in a variable called score, I could say score equal class scores and then 1 sub 3. And that is going to give me a 7. Or I could even say class score 8, 4. That's going to give me, another 7, but it's a different spot. But I can't say scores open parentheses 8 comma 4 close parentheses. That is not legal in C and C++. It may be legal in other languages, but you have to look at how the array notation looks like for multi-dimensional arrays in these languages. So a two-dimensional array is implemented as an array of pointers to the arrays. This concept becomes very important if you're going to create arrays dynamically when the program is running. So I have an array of pointers, and then I have an array here. So the address of this array is going to go into the first pointer. The address of the second array goes into the second pointer. The address of the third array goes into the third pointer. Well, and think about that one if you're going to do those dynamic arrays. Let's go back and look at int main. Int argc is the argument count, and character star argv. This contains a list of strings that are part of the argument. For example, if I say copy file1.txt, file2.txt, and I do this on the command line, copy goes into argument index 0, file1.txt goes into position 1 and file2.txt goes into position 2. So then you can pull this information out into your program. So far we haven't used it. There's another one that's similar. Instead of argc and argv, I can have a list of environment variables that belong to the operating system. So we can also get that information into our program. That's about all there is right now. Have fun with pointers. Again, if you find this a little bit confusing, well, don't feel too bad, because I certainly didn't catch on to pointers the first time I saw them. I really didn't even have anybody to explain them to me, which even made things worse. So if you do have a problem with it, there's two things to think about. One thing is you can go back and look at the video again, and after you look at it again, well, if you want to look at it a third time, that's cool too, but if it's still confusing, this stuff here won't be really totally clear until you use them a whole bunch of times, and bunches of times. That's certainly the way I found out, is just use them over and over again. So have fun with pointers. Cheers.